Welcome to Module 6, Lesson 14, checking for identical triangles again. Okay, but a little bit different in contrast to Lesson 13, where you actually examined pairs of distinct triangles. The triangles in this lesson are going to be attached, okay, in some way, shape, or form, as you can see here. And if you look, both of these are sharing sides, both examples here. If you look at these two and these two, they are sharing sides, so therefore they are attached. And we'll talk about things that we can do to help with that and to help us solve and to be sure, okay, if we are looking at necessarily looking at identical triangles, okay. And you'll also be asked to kind of go back into your memory in terms of different relationships amongst angles, okay, and those angle relationships, special angle relationships. One in particular comes up in this lesson, and you'll be asked to use that to help you solve the puzzles here, whether we can claim uniqueness and whether we can claim truly identical triangles, okay? So, yeah, let's get started. Okay, so in each of the following problems, you're going to determine whether the triangles are identical, not identical, or not necessarily identical, okay? And justify your reasoning. If the relationship between the two triangles yields information that establishes a condition, I want you to describe that information. And if the triangles are identical, of course, write that ever-important triangle correspondence that matches the sides and angles, okay? All right, so here, example one. Let's go ahead and do example one here together. Again, yeah, just justifying that. So you notice we have a situation where we are sharing a common side, okay? So if we have these two triangles, we're going to pull one out like that, okay? We're going to create that triangle right there. Okay, so now we have our two triangles. Okay, we're going to try to disregard that other one that's there, this one right here. Okay, we'll just disregard it. But we're going to look at these two new triangles we've kind of created. We just pulled them apart. Okay, they share a common side, which is very important here. Okay, and there is that common side. Okay, there we go. I'm just trying to fix this up here to make these tick marks work correctly. Okay, and as you see, we had already been given the fact that some of these sides were already equal, okay, there and there. And then we had there and there. And now we know these two are because that is a common side, and therefore, of course, it's going to be the same. And you could probably recognize what condition this fills, and that fills the three sides condition. And therefore, we have identical triangles. Now, important is that correspondence, and we go with their ZWY right there. If we're going to go in that order, ZWY, we've got to follow that it is correspondent to XYW, okay, because it's going to follow in the same direction, okay? All right, so equal sides and equal angles all correspond, okay? So why don't you go ahead and do exercises 1 and 2 by yourself. Come back and we'll talk about it. Okay, so let's see, exercise 1 here asks us, are the triangles identical? Okay, so if we go ahead and just take a look here, and let's just go ahead and pull out that triangle, okay, and cross out the other one. Okay, and just make note of what we have so far. We have triangle RQT on one side and triangle RST on the other side, and there it is. Okay, and we can see we have those two angles that are equal right over there, angle Q and angle S. All right, and we have two sides that are equal as well right there. Okay. And if we look, we have another side, that shared side, which is also going to be equal. All right. So therefore, we have, looks to me like we have two sides and an angle. And what do we know about two sides and an angle? Well, we know that two sides and an angle are going to, oops, I got to get by this here. I'm going to get by that. Okay. Oh, wait, hold on. Sorry. You know, I had a little bit of technical difficulty. Hate to admit that, but I'll be back. So sorry. I don't want to get into what happened, but I had this whole thing recorded already, and I went and saved part of it and don't know where it went. I'm sorry, but if this whole beginning of this thing is messy, excuse me. Anyway, let's get back to this example 1 here. Yeah, an exercise 1, not example 1, but exercise 1. Okay, so if we look at these two here, okay, we have our triangle RQT, okay, right there, and then triangle RST over here. Okay, we're trying to uncover if they are indeed, just want to erase some of this mess over here. They are indeed identical. Okay, now on the surface it would look like it. We have an angle, we have two sides. Here's the problem though, okay? These two sides that we have, okay, are not necessarily going to give us enough to say that they are identical, okay? Because we have a non-included, if you remember, a non-included acute angle, okay? And here is that non-included acute angle right over there, okay? We have these two sides. We have side, side, yes, good, match up, side, side, match up, that's great, two sides. But the angle that we have is not included, okay, and again, we'll talk about this later again, but non-included means it doesn't work right in a row. We don't have side, angle, side, okay, this situation. If you have side, angle, side, this idea, they are included, okay, you have an included angle there. We don't have that in this case, okay? It's a non-included angle. And that non-included angle, if you remember from last lesson, if it is acute and it's not going to help us out, okay? Because we could draw that. Remember, we could draw a circle, and we could have two different intersections with the line. Okay, so therefore it doesn't work. So this is going to be and exercise 1 here is not necessarily identical, okay? Not necessarily identical. Okay. Okay, so here we are in number 2. Are the triangles identical? Justify your reasoning. All right. First thing I want to do is go ahead and pull that other triangle out, okay, and have it there on its own. Cross this other one off right there. Okay, so now we're looking at two separate triangles, okay, and a couple pieces of information we need to make note of here. We need to note that F is a right angle, and therefore because those two lines, okay, line here and here, must have been perpendicular to create that right angle. It also created a right angle on the other side as well. Okay, so just so we know that, all right? Okay, and there's my little right angle symbol underneath there that I hid. Okay. All right, there we go. So we have two angles that we know are similar here. Okay, two similar angles, and we have, of course, our similar side, all right? And most importantly, those sides are opposite of a given angle, which happens to be the same given angle, okay? Therefore, we can say they are indeed identical, okay? Identical, and here is our correspondence, and a correspondence is, of course, based on this here. So we have EFH corresponds to triangle GFH, okay? All right, so, and again, the the reason for it was we had two angles and a side condition. Okay? Okay, super. Alrighty, and let's move on to this next section. Okay, and here we have example 2. All right, and are the triangles identical? And justify your reasoning. Now, I'm going to have you just take a look at that and see what you can come up with, because I want you to reach back into the recesses of your memory to see if you recognize something about a couple of angles in this one that can help you out. A couple of little bit of information that can help you solve this mystery. All right, so go ahead and give that a whirl. Just take a look at it, and then we'll look at it together. Okay, so let's see if you recognize something about these two triangles, and hopefully you did. Hopefully you reached back and remembered. Well, just right on the surface here, you can see that we have two sides that are equal. Okay, so we have our two sides, and we have some conditions where two sides will indeed help us to make the claim of a unique triangles or identical triangles, but we need something else, okay? And we are looking right there, and if you noticed right there where those two lines intersect, okay, and that would be, we have angle AOC, angle AOC, and then we have angle DOB, angle DOB, okay? They are, if you remember, vertical, oops, I wrote over my thing. Yeah, vertical angles, yes, vertical angles. And what do you remember about vertical angles? Yes, indeed, they are equal, okay? Therefore, we have our two sides and an angle, an included angle, actually, and no less, okay, an included angle. So we have two sides and an included angle. Therefore, they are indeed identical because they meet that condition. Alrighty, so let's move forward. Okay, so why don't you go ahead and do exercises 3 and 4, which are going to follow in a similar pattern to the one we, a similar style, the one we just did together. So go ahead and do them, and then come back and we'll check in. Okay, so let's look at number 3 here. And number 3, you notice we have two sides. We have a side, well, actually one side so far. Okay, that is equal. And then we have one angle that we are shown. Okay, one angle. But of course, if you notice, we have some vertical angles. Therefore, we have two angles. One side and two angles. And the side happens to be opposite. The opposite and included angle right there. Okay, therefore these are indeed identical, and hopefully you were able to see that with no problem. Okay, let's go ahead and take a look at number 4 then, and we'll see what we get from there. Well, I hope you didn't let this one trip you up, and you did remember again to earlier lessons in this module, or this topic actually. Are the triangles identical here? Well, what we see is we have 1 and 2 angles that we are being given, okay? And we also know, because these are vertical angles right here, that these as well are equal. Therefore, we have 3 equal angles, okay? We're given 3, I shouldn't say 3 equal angles, but we have three given angles. And if you remember way back when, now three given sides was or is a condition for unique triangle, okay, and therefore reproducing identical triangles. But if you do recall way back when, that three given angles does not necessarily, so this is not necessarily, these are not necessarily equal, okay, or identical. Okay, not necessarily, because if you remember, with angles we could have, a triangle like this but then that triangle, if we draw it to scale larger, these could be identical in their angles, okay, but not necessarily identical in their size, for example. Okay, so hopefully you were able to get by that one with flying colors. Okay, and now we have exercises 5 through 8, and they are, I see a couple of kites right here that they're making, and if you go ahead and just try those on your own and come back and we'll do them together. Okay, so these kites, like some of the attached triangles before, need to be pulled apart. Okay, well, I don't need to be, but it makes it a little bit easier for me and hopefully for some of you as well. Okay, and what we end up with here is we end up with two sides and a non-included angle of 90 degrees or more. Okay, because this is, of course, designates our 90-degree angle. Okay, right there and there. All right, so two sides of a non-included angle. And again, this non-included, I'm not sure if we talked about that enough, but I mean, it's non-included. It's not included because it's not in between, okay? It's not, see, if we had this side here, for example, this side here was the same, it would be included in this whole angle right here. We'd have side, angle, side, okay? But as we don't have that in this case, we do have two sides, but we have this non-included angle, but it is 90 degrees or more, okay? And that is the key. Remember, if we have a 90-degree angle or if we have an obtuse angle, which is greater than 90 degrees, we can create identical triangles from it because those would be conditions for a unique triangle, okay? But less than 90 degrees would not hold up. So go ahead and do numbers 6 and 7. You probably have already, but anyway, I'm going to pause for a second and come on back. Okay, so before we talk about 6, which I've actually left drawn down there, didn't want to, but I just wanted to just finish up on 5. We didn't write down the correspondence. So the correspondence was we had triangle MPO corresponded to triangle NPO. Okay, just wanted to get that out of the way. Didn't want to neglect that because those were identical. So now if we get down to here, the triangles in 6, again I pulled them apart. And what we do notice is we do have two sides, okay, two sides of equivalent sides there, two pairs of equivalent sides. But the angle that we are given, okay, is non-included, okay, it's a non-included angle right here, but it is an acute angle, okay, and because it is an acute angle, we can not necessarily say that they are identical. So we're going to say not necessarily identical. Okay? Alrighty. Let's go ahead and finish this up. We have one more set of triangles, and then we'll be done. Okay, well, this last one was Pretty darn easy, huh? So it is indeed identical, okay, because it fits the condition of, two angles, okay, pair there, and of course the sides, the given side right there, and that side happens to be opposite of the given angle. Okay, so yes, it is identical, and those two correspond as triangle RWS corresponds to triangle RWT. Okay? All right, so number 8 here says create your own labeled diagram, a set of criteria for a pair of angles. Ask a neighbor, or ask your mom, dad, sister, brother, friend, if you'd like to do this, to practice a little bit, but I'm sure you'll get some practice doing this in your problem sets. So, with no further ado, let's go ahead and close this lesson here. In deciding whether two triangles are identical, you examine the structure of the diagram and the two triangles to look for a relationship that might reveal information about corresponding parts of the triangles. Okay, and that was the huge point here in this lesson. Okay, because we had cases where these vertical angles helped us out a lot. Okay, helped us out a lot. Those vertical angles became our second pair of equal angles at times. So yeah, so we used our knowledge. This information may determine whether the parts of the triangle satisfy a particular condition, which might determine whether the triangles are identical. Okay, so we just kind of added that in. We also talked about the strategy. You have two triangles that are attached like this, just for your sanity and to make it easier for you. Just separate those triangles like that, and in writing, and then work it that way. Okay, and again, keeping that correspondence, making sure that is correct. Okay, well, good luck with everything, all your problem sets and such, and see you soon.